Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we'll explore network segmentation and microsegmentation, two foundational strategies for securing complex environments, minimizing risk, and protecting sensitive data. As networks grow in size and complexity, the need to isolate, control, and monitor traffic between systems becomes essential. Without segmentation, networks operate like open floor plans, everything connected to everything else, with few barriers to stop a malicious actor from moving laterally once inside. Effective segmentation helps stop that movement, keeping threats contained and giving defenders time to respond. Let's start with the importance of network segmentation. At its core, segmentation divides a larger network into smaller manageable parts called segments or zones. These segments are often based on business function, system criticality, sensitivity of data, or levels of trust. For example, an organization might separate its human resources systems from its accounting systems, or its guest Wi-Fi network from its internal production network. Segmenting a network reduces the attack surface. If an attacker compromises one system, segmentation can prevent them from accessing others. It limits the lateral movement of threats, meaning the ability for an intruder or malware to spread across different parts of the network. This kind of containment is crucial for stopping breaches before they escalate. Segmentation also supports compliance by enabling more granular control over data flows. Regulatory frameworks often require that sensitive information such as personal health data or credit card numbers is isolated from general-purpose systems. By segmenting the network, organizations can ensure that only authorized users and systems can access sensitive environments. Another benefit is improved operational reliability. Segmenting networks helps control broadcast traffic, manage congestion, and reduce the impact of misconfigurations. It also simplifies troubleshooting and monitoring because network administrators can narrow the scope of issues based on where they occur. Now let's explore some of the common techniques used to implement network segmentation. One of the most widely used is the Virtual Local Area Network, or VLAN. VLANs allow administrators to logically separate network traffic without requiring physical separation. Multiple devices can connect to the same switch, but be placed into different VLANs that act as isolated groups. VLANs help create boundaries and enforce policy without adding hardware. Another powerful segmentation tool is firewall zoning. This involves defining clear network zones, such as internal, external, DMZ, and restricted. Each zone has specific access rules and traffic controls. A demilitarized zone, for example, may host web servers that are publicly accessible, but still separated from internal systems by strict firewall rules. Firewall zoning provides control at the boundary level, helping to prevent untrusted users from reaching trusted systems. Subnetting is another technique that helps break larger IP address spaces into smaller logical groupings. Subnets reduce broadcast domains and allow more precise traffic management. Although subnetting alone doesn't enforce security, it lays the groundwork for applying access control lists and route filters that can. In some high-security environments, physical isolation may be used. This means building separate networks using dedicated cabling, switches, or even air gaps. This approach is costly, but may be required for highly sensitive operations, such as military systems or critical infrastructure components. Now let's dive into microsegmentation. If segmentation is about isolating entire groups of systems, microsegmentation takes that concept further, down to the level of individual workloads, applications, or even processes. It is typically implemented in virtualized environments, cloud infrastructure, or containerized applications where traditional boundary-based segmentation falls short. With microsegmentation, every workload is treated as a separate unit with its own security policies. These policies define who or what can communicate with it, under what conditions, and with which permissions. This fine-grained control enables organizations to prevent one compromised application from impacting others, even if they reside on the same host or virtual network. Microsegmentation is a powerful defense against lateral movement. Even if an attacker bypasses traditional perimeter defenses, they may still be unable to access other resources if microsegmentation controls block that traffic. Deploying microsegmentation typically involves the use of software-dedicated networking tools, next-generation firewalls, and policy enforcement engines. These solutions monitor and control traffic between virtual machines, containers, or services in real time. They often rely on automation to classify workloads and assign rules dynamically. For example, an organization might use microsegmentation to allow a front-end web server to communicate with an application server, but block that web server from reaching a database directly. Only the application server would be allowed to connect to the database, and each connection would be logged and monitored. Now let's talk about how to implement effective segmentation and microsegmentation practices. Start with a documented policy. Define your network zones, the data or systems they contain, and the rules for communication between them. Assign ownership and responsibilities for managing these zones and ensuring proper access control. Use strong access control mechanisms at the boundaries, whether it's a firewall between two zones or a policy engine controlling service-to-service communication. Ensure that only authorized traffic is allowed. Require strong authentication for administrative access to segmentation controls. Make logging and monitoring a central part of your segmentation strategy. Collect data on allowed and blocked connections. Use that data to refine your rules, detect anomalies, and identify violations. Centralized logging systems, security information and event management tools, and intrusion detection systems help enforce and verify segmentation boundaries. Regularly test your segmentation controls. Conduct vulnerability scans and penetration tests to look for paths that violate your intended design. These tests can reveal misconfigurations, overly permissive rules, or undocumented connections that could be exploited. Combine segmentation with layered security tools. Deploy intrusion prevention systems, endpoint protection platforms, and secure baseline configurations within each zone. Segmentation is not a silver bullet. It must be part of a broader defense in-depth approach. For more cybersecurity content and books, please visit cyberauthor.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. You can also explore more CISSP support at baremetalcyber.com. Let's now turn to continuous improvement in segmentation strategies. Start by reviewing your segmentation design regularly. As new systems come online, applications change, or business needs evolve, your segmentation plan must evolve with them. An outdated segmentation design can create blind spots and increase risk. Use incident data to inform your improvements. If an incident spreads between systems, ask whether better segmentation could have contained it. If unauthorized access was gained, ask whether tighter microsegmentation would have blocked the path. Conduct audits of your segmentation controls. Verify that rules are correctly applied, that access lists reflect policy, and that firewalls are operating as intended. Look for signs of rule creep where old or unnecessary rules are left in place and remove them. Involve multiple teams in segmentation management. Network engineers, system architects, security analysts, and compliance officers all have roles to play. Collaboration ensures that security goals align with operational realities and regulatory requirements. Educate your teams. Administrators and developers must understand how segmentation works, why it matters, and how their actions can impact security. Provide training, documentation, and hands-on labs to build awareness and confidence. Be proactive in testing new segmentation technologies. Explore zero-trust network access models, software-defined perimeter solutions, and adaptive segmentation tools that use machine learning to recommend or enforce policies. Evaluate how these tools can support your organization's resilience and scalability. In summary, network segmentation and microsegmentation are no longer optional. They are essential practices for managing complexity, securing infrastructure, and preparing for the inevitable attack. By dividing the network into logical or functional boundaries and enforcing strict communication rules, organizations gain visibility, control, and peace of mind. Thank you for joining the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Deepen your understanding of network segmentation and microsegmentation, and will consistently support your journey towards CISSP certification success.